Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Recursion that we had made, we had solved this get stair paths problem. So in this problem, we were given a number of stairs, right? And we had to descend from the stairs to the ground. And there were some conditions associated with it, like if we can we can descend one step at a time, or we can descend two steps at a time, or we can descend three steps at a time. So the approach that we had used to solve this question was that we we have a source and then we have a destination, and in between the source and destination there were some intermediaries. So we had the intermediaries like n minus 1, n minus 2, and n minus 3, and we set the fate that this gets straight paths n minus 1, n minus 2, and minus 3, we will get all these, right? Like we had set multiple fates there. And once we get the array list, so if we just prepend 1 in front of all these, prepend 2 in front of all these, and prepend 3 in front of all these, then we would get our final paths, right? So that is how we had solved this question. So in this video, let's continue to solve the next question, which is this get maze paths question. So we are given a number n and a number m representing rows and columns in a maze. You are standing in the top left corner and you have to reach the bottom right corner. Only two moves are allowed: horizontal, that is one step horizontal, and two steps vertical. Complete the body of the getMaze function without changing the signature to get list of all the paths to move from top to the bottom. Okay, so let's let's understand what this question is trying to say. So let's first assume that we are given the m and n as 3, 3. So we will have a maze which is like a 3, 3 maze, which is of size 3, 3. So let me draw that first. Let me have some lines here. So this is a maze of 3, 3, let's say. So we'll have this as, okay, let me have a brush. This as 1, 2, 3, and this again as 1, 2, and 3. Yeah. So we are standing here and we want to get, like, this is the source that we have and this is the destination that we have, right? And we have to print all the possible paths to get from the source to the destination. So what are the possible paths for going from 1, 1 to 3, 3? Let's print those here once, okay? So we'll store those paths in an array list so we can move horizontally, and then vertically two times. Then so that is the first part. That is HHVV. The second part is we move horizontally, vertically, then again we move horizontally, vertically, then again horizontally and vertically. HV, HV. And the third path that I can think of is we move horizontal, vertical, vertical, and then again horizontal, like this path. We move horizontal, vertical, vertical, and then again horizontal. Okay. Yeah, so that's all the paths that I think I can think of from this. Okay, so we have moved from HHVV, and then we moved from HVHV, and we also moved from HVVH. Okay, and then let's consider the paths from this column. Okay, so if we move VVHH, that is a path, right? VVHH is one path. Then VHVHHV is another path. Is another path. And then VHVH is another part. VH. Mm, yeah, so that's all the paths, right, that I can think of. Let me just once again go through these. So we have VHH, then VH, VH, VHHV, and then VHVH. Yeah, so that's all the paths I can think of, right? So how do we approach this? Like this is the expectation that we have, and yeah, so let's copy this, and we'll approach this question in the same way. Like we set some expectation, then we have set some faith, and then we move from the faith to the expectations. So we have the expectation that this get maze path function, it will return an array list. Get maze paths function, if we are at, like we will use this method signature. If we are at source row 1 and source column 1, and we have to move to source destination row 3 and destination column 3, then we'll have the expectation set like this function will return us this array list, right? So we have 1, 2, 3, 4, 5, 6, 6 ways of going from 1 comma 1 to 3 comma 3. Like this is the expectation that we have set. Now let's set some faith. So let's set some faith, like mm, here also we'll have to set multiple faiths. Okay. So this is a typical problem, like if we have to go from some source to the destination, then we will use this approach. We'll use this common approach. So we'll have uh, the source as 1 comma 1, right? Like this is the source that we have, 1 comma 1. And what's the destination that we have? The destination we have is 3 comma 3. Okay. And what should be the intermediaries between this 1 comma 1 and 3 comma 3? So if we move horizontally, then we will get somewhere. So we'll have that as an intermediary. If we move vertically, we'll get somewhere. Okay, so if we move horizontally, we will get to this column, right? Which is 1 comma 2. So this is 1 comma 2. And if we move vertically, we'll get to this column, which is the row is 2 and the column is first. So we can have these as the intermediary paths. Let's say I1 and I2. And there are n number of ways using which we can move from this intermediary paths to the destination. Yeah. So if we assume this as the faith, then uh, we can have an array list. Okay, so let's assume the faith that we know how to get from this intermediate destination to the destination, from this intermediate to the destination. Let's assume that. So we'll assume that we know the get maze path function. So we'll assume that we know this function, right? Get maze path from the source row. Okay, just a minute. Yeah, from the source row 1 to the source column 2, we know how to get to destination row 3 and destination column 3. So we'll assume that. So from source row 1 to source column 2, we know how to get to this 3 comma 3. And let's discuss how we can get there. So let's say if we are here, right? So how will you get from here to the destination? Let's discuss that. So I can see that we can go horizontally, then vertically, then we can go vertically, horizontally, and then vertically, VH, VHV, So just imagine this VHV, and then again we have an option to go um, we have an option to go horizontally and then horizontally vertically, right? Have we considered? Okay, let's consider it again. So we'll first path is HVV, second part is VHV, then third part is VVH, right? VVH. I can think of these paths. So we know these. Okay, let's not write that. We know this, and at the same time, we know how to get from here from this 2 comma 1 column 2 comma 1 this coordinate to the destination 3 comma 3. So let's write the path for those as well. So the first path we write is VHH, meaning we can go vertically, then vertically, like we are here, then we can go vertically, then horizontally. Then the second part that we have is going HHV, right? We go HHV. The third path that we have is we go HVH. Okay, HVH. That is all the paths that I can think of. So we assume that we know these two paths, like these two intermediary stops. Um, how do you get from these two intermediary paths to the destination? We assume that we already know this. Okay, so I should have copied this. Okay, but never mind. So we'll have HVV and then VHV, VVH, right? Yep. And then we also know that if we are at source row 2 and source column 1 and we have to reach at the coordinate 3 comma 3, then we know these paths as well. Like this is the fate that we are setting. Okay, so we can get using VHH or HHV or HVH. Okay, this is the expectation that we are setting. Now, if we observe carefully, how do we get from fate to expectation? So if we observe carefully, we have this array list, and if we append h in front of all these, we will get these first three. Okay, and if we append v in front of all this, then we'll get these last three elements. Okay, so what we need to do, we need to iterate over the array list, over faith array lists. Okay, and append h in front of al1. Let's say like this is, let's say al1, and we can append v in front of al2. This is how we can go from the faith to the expectation. Okay. So yeah, let's try to write the base case here. Not the base case. Let's first write the code here. Let me copy this. And the question is get maze paths, right? Get maze paths. Yeah. So we'll have two entries, right? Enter number of rows, enter number of columns. So this is, let's say, rows. This is columns. Then we call this get maze paths function. and this get maze path function should return an array list, but let's erase all this code. And then we have int source row, int source column. We also have int destination row, int destination column. Okay, we'll call this the source row will be always 1 comma 1, right? And the destination rows and columns will be 3 comma 3, not 3 comma 3, the rows and columns, right? We are assuming those 3 comma 3 for the example. That's why I wrote it. COLUMNS. Yep. And let's write the faith. So we have the faith that this guess made paths with source row comma source column plus 1 plus, okay, I'll have to switch the numlock on, will give us all the paths. Okay, so let's say this is array list 1, and then we'll have again an array list 2. Then we iterate over this array lists. Okay, we iterate over this array list. Oh, okay. We have integer array, right? Have to be sure. Mm, do we have an integer array? No, right? We have a string array itself. My bad. Yeah. So we'll have string path 1. Okay. So we'll get all the paths here, and then we'll just append. So we'll have to create a new array list for that. Array list string, right? El is equals to new array list. We can call this as a result, maybe. Yep. So we have result dot add. What do we append here? So we are at path. We have assumed that we are at this path, right? If we move horizontally, then the row count increases. So we'll append h here. Append h here. Path 1, let's say. And we again iterate over this second array left. See path 2, and we append v. Yep. And then we just return this array left result, right? Yep. I think this code will work, and let's analyze this now. Let's have it in our paint, and let's try to figure out the base case for this. Let me decrease the font of this maybe. Yep. So yeah, let's analyze the base case that we have. Okay. So we are at column 1 comma 1, then we go, then this is called, right? So here we are having multiple calls, multiple recursive calls, so it's better that we have a Euler's diagram. So if we move horizontally, we'll come at 1 comma 2. Okay, I'll have to maybe have this smaller. So let me have 1 comma 1 here because the tree is going to be big. Then we have two paths from here, right? So if we move horizontally and if we move vertically, if we move horizontally, we'll be at column 1 comma 2. If we move vertically, then we'll be at column 2 comma 1. Okay, then again we'll have two paths from here. If we move horizontally, we'll be at 1 comma 3. If we move vertically, then we are at 2 comma 2. Then we'll have two paths from here as well if we move horizontally and vertically. If we move horizontally, we increase the row count, right? If we move vertically, then we increase the uh, if we move horizontally, we increase the column count, not the row count. If we move vertically, then we increase the row count. So we increase the row count. Again, from here, if we move horizontally, we'll increase the row count. If we move vertically, then we'll increase the sorry, if we move horizontally, we increase the column count. I keep saying row count. Yeah, my bad. Yeah. Then again, we have two options from here as well. If we move horizontally, then we increase the column count. I got it right now. If we move vertically, then we increase the row count. Again, from here, if we move horizontally, we'll have 2 comma 3. If we move vertically, then we have 3 comma 2. And from here as well, we'll have two branches. If we move horizontally, we'll increase the column count. If we move vertically, then we increase the row count, which is 4 comma 1. Again, for there are some cases for this tree now that are out of the maze. So we'll draw the maze here somewhere. We'll draw the maze here. Or let me have it here. So this is the maze that we have. And we have the row counts as 1, 2, 3. Column counts as 1, 2, 3. Yeah. So this 1 comma 4, where is it? It is out of this maze. So that is one base case that we have. If 2 comma 3, it is inside the row. So we can have some more branches of this, right? So we'll mark, maybe we can mark, yeah, we'll mark, okay, let's mark them afterwards. Okay, so if we move horizontally from here, horizontally we increase the column count. So we are at 2 comma 4, and if we move vertically, we are at our destination coordinates, which is 3 comma 3. Similarly, if we move horizontally and vertically, so move horizontally from here, we'll be at 2 comma 4. If we move vertically, then we are at 3 comma 3, which is our destination. Again, if we move, we have two options from here as well to move horizontally and vertically. For horizontal, we will go to our destination from here. For vertical, we will uh, increment the row count, right? 4 comma 2. Again, from here as well, we'll have two options to go horizontally and vertically. If we go horizontally, we'll increase the row column count, and if we move vertically, we increase the column count. Increase the row count. My bad. Again, from here also, we'll have two options to go horizontally and vertically. If we go horizontally, we'll be at 3 comma 3, which is our destination. If we go vertically, we are at 4 comma 2. And here also we'll have two options, right? So if we move horizontally or vertically, if we go horizontal, we'll have be at 3 comma 3. If we go vertically, then we'll go for 4 comma 2. And we have not considered these options, right? 4 comma 1 or 1 comma 4, because we are already out of this maze. So 4 comma 1 will be somewhere, will be the fourth row, right? The fourth row will be somewhere here, and the first column, like this is the coordinate, but that is out of the maze. So these conditions will help us identify the base case. So let me have a broader pen. So we will identify some naughty base cases. So this is one naughty base case because we are going out of the maze. This is other naughty base case. This is another naughty base case. This is another one. This is another one because we are going out of the bound here, right? Then we'll have this, this. So how do we identify the naughty base cases? So we can have some condition like if we can have something like if row count is greater than the destination, if the source row is greater than the destination or something like that, right? So let us try to write that condition. Or what we can do is we can have conditions specifically to call these functions only when, like these functions will be invoked when the source row and the and the source column are within this boundary that we have. Okay, let us try to write that. So I'll write some code here. If source row is less than destination row, then only, okay, then only we will, then only I think we should increment the source column, right? And if source column is less than the definition column, then only we should call this or this. Okay, but I'm just thinking, if source row is less than, then only we should increment the source row, right? Yeah, for we have messed the conditions, like we'll have them something like this. If source column is less, then only we increment the source column, right? Otherwise, if not, then we don't increment. So what we can do is that we can have this 2RLF instantiated outside. So let me have this AL1 and AL2 instantiated outside. So what will happen is, okay, and we can have those instantiated as well, like with new array list. Let me copy that here. Yep. If source column is less than definition column, then only increment the source column. Yeah. So this is the edge cases, the naughty edge cases that we are handling. So what will happen if the count comes here? Let's discuss that. So here the source, let's say the source row is 1. Like let's discuss for this 1 comma 3 condition. Okay. So we'll have this call somewhere, right? Source row is 1 and definition column is 3. And then the flow will come here. Okay, let me copy this code here. Like this function will be invoked, and what do we check first? If the source row it is less than the destination row, 1 is less than 3, so we will increment the source row. Okay, so by incrementing the source row, meaning we are incrementing the row count when we are going vertically. So basically we just move vertically, we don't move horizontally. Okay. And for the second condition that we have, which is if source column is less than the destination column, which is wrong in this case, right? 3 is not less than 3, 3 is equal to 3, so we don't execute this code. Like, meaning we don't have the left call, meaning we don't go horizontally. That's the meaning of this. So this naughty base cases won't be executed itself because we have these if conditions implemented. So this is us handling the naughty edge cases. Now let's try to handle the base case that we have. Okay, so the base case will be something like if we are at the destination coordinates, then we'll have one option. Okay, so that one option we will represent by having an array list with an empty string. Okay. So that is how we had done for the get stair paths. So if we are at the 0th path, we'll have one option, and that one option is represented in an array list by having an empty path. So if source row is equals to destination row and source column is equals to destination column, then we'll have one. Oops, I wrote one. I wrote and literally. Then we'll have one option, and that one option will be represented using something like this. El is equals to new array list dot add. We add an empty string and we just return it. Yep, return this array list. Yeah, so I think this code might work. Let's try to run it once. The number of rows is 3. Oops, my numlock is locked again. Yeah, so we have this as the output. Let's compare it once with the expectations. HHVV, HVHH, HVVH, VHHV. Okay, so we missed one path here, right? Okay. Okay, so is this 2 times? No, right? 1, 2, 3, 4, 5, 6. Yeah, there's uh, some discrepancies in the order, but it's fine, right? Yeah, we have covered all the possibilities. Yeah. So yeah, that's all for this video. See you guys in the next one. Thank you.